Welcome back to our beginner Golang programming series. In today's lesson, we're going to dive into a crucial topic, control flow. Control flow allows us to make decisions and control the flow of our programs, and it's essential for writing efficient and organized code. By the end of this lesson, you'll have a solid understanding of conditional statements, switch statements, looping constructs, and how to break or continue loops. Stay tuned to the end where I will also explain how to avoid infinite loops in your code. So, let's get started. Let's begin with conditional statements. Conditional statements are like forks in the road that guide our program's execution based on certain conditions. In Go, we have three main types of conditional statements: if, and else. They each direct your program to execute different blocks of code depending on whether a specified condition evaluates to true or false. Let's explore these concepts with a few basic real-world examples. In this example, the program checks if age is greater than or equal to 18. If this condition evaluates to true, the program will execute the code within the block and print, "You are an adult." Then the program's execution will stop as there is no more code to execute. However, if the condition evaluates to false and age is less than 18, nothing will be printed and the program's execution will stop, again as there is no more code to execute. Let's look at the else statement now. In this example, the program checks if the temperature is greater than or equal to 30. If it is, then it executes that block of code and prints, "It's a hot day." However, if the temperature is not greater than or equal to 30, then the program will arrive at the else statement and it will execute that block of code and it prints, "It's not too hot." If with else will allow you to handle a true and false outcome of a condition. Now let's look at else if. Can you guess what will happen here? Let me know in the comments below if you guessed correctly. In this example, the program evaluates different conditions using else if. It checks the value of the score and prints different messages based on the score range. You will probably find yourself using else if quite often. One of the things to remember is that only one of the statement blocks will be executed. As soon as one of the blocks within an if statement is true, then that single block will be executed and the code will continue after that point. In our final example for conditional statements, I thought I should show you how you can nest if statements. It first checks if it's raining, and if it is, it further checks if the person has an umbrella to decide whether they'll get wet or not. You should be careful with nesting if statements, it can make your code hard to read. If possible, it is best to refactor such functions into smaller bytes for ease of reading and support. Conditional statements in Go are fundamental for making decisions in your programs and creating logic flows based on various conditions. They allow your program to react and respond dynamically to changing situations, just like you would in real-world scenarios. In Go programming, a switch statement is used to make decisions based on the value of an expression, making it quite similar to an else-if statement. It's a control structure that helps you avoid writing a series of if-else statements when you need to check multiple conditions for the same variable. The main difference between an else if and a switch is we place the variable to be used in all of the evaluations at the top, then add additional cases to test against. Once it is evaluated, it is tested against each case within the switch. If one of the switches is true, then the code within that case will be executed. If none are true, then the default block will be executed. A switch statement can be quite powerful and efficient in many cases. In switch statements, it is possible for more than one block to be executed if more than one case evaluates to true. This is why we use the break statement between blocks to stop execution of additional cases after the first one has been evaluated to true. More on this later in the lesson. Let's say you want to determine the type of activity based on the day of the week. You can use a switch statement like this. We evaluate the current day of week and assign activity depending upon the day. It's Friday for me. I guess that's why I am working. This demonstrates how the switch statement helps you choose different paths of execution based on the value of an expression. It's a cleaner and more readable way to handle multiple conditions compared to chaining multiple if-else statements. Let's move on to loops. A loop is a fundamental control structure used to execute a block of code repeatedly for a certain number of times. A for loop in Golang consists of three parts: initialization, condition, and post statement. The loop continues to execute as long as the condition remains true. For loops are commonly used when the number of iterations is known beforehand. This code snippet is using a for loop in the Go programming language. It's designed to repeatedly execute a specific block of code. Let's break down what each part of the for loop does. The starting point of the loop. It initializes a variable I with the value 1. This variable will be used to keep track of the current iteration. The next part is the condition that needs to be true for the loop to continue executing. It checks if the value of I is less than or equal to 5. As long as this condition is true, the loop will keep running. The third and final part of the statement is the post statement that gets executed after each iteration of the loop. As in when the statement is complete and is ready to run again. It increments the value of I by 1, effectively moving to the next number for the next iteration. In other words, this for loop starts with I as 1, prints the value of I, then increments I by 1. It repeats this process until it reaches a value greater than 5. As a result, the loop will print the numbers from 1 to 5 in the console. Now let me introduce you to while loops. Go does not have a dedicated while loop. However, you can achieve the same effect using a for loop with just a condition. This makes the loop run as long as the condition is true. This code snippet is using a while loop-like structure in Go. Here's a simple explanation of what it does. Here we initialize a variable I with the value 1. This variable will be used to keep track of the current number being processed in the loop. Notice how this is done outside of the for statement itself this time. Now we declare the for loop itself. It continues running as long as the condition I less than equals 5 is true. This is similar to saying, keep doing what's inside the loop as long as I is less than or equal to 5. Finally, we have the statement that increments the value of I by 1 after each iteration of the loop. It's like moving to the next number for the next iteration. Notice how this is within the for loop this time. So, when you put it all together, the loop starts with I as 1, prints the value of I, increments I by 1, and then checks if I is still less than or equal to 5. It repeats this process until I becomes greater than 5. As a result, the loop will print the numbers from 1 to 5 in the console, just like the previous example. In essence, this loop structure is a concise way of achieving the behavior of a while loop, where the loop continues while a specific condition is true. So what happens if we don't include an expression to test upon? That's how you get an infinite loop. An infinite loop is a loop that runs indefinitely unless interrupted by external factors or deliberately terminated within the code. This can be achieved by omitting the loop condition in a for loop. Infinite loops are useful for running tasks that should continue indefinitely, such as server programs. It's important to exercise caution when using infinite loops, as they can lead to programs that do not terminate and may require manual intervention to stop. In summary, for loops are versatile and allow you to specify initialization, condition, and post statements. While loops can be emulated using for loops with only a condition, and infinite loops can be created by omitting the loop condition. Understanding these loop constructs is essential for controlling the flow of your Go programs effectively. Now let's look at break and continue statements. Break and continue statements are not exactly control flow statements, but they are used within control flow statements to help control the flow of your code. So, in Golang, the break and continue statements are used to control the flow of loops. They allow you to exit a loop prematurely, break, or skip the current iteration and move to the next one, continue. Let's explore these concepts using basic real-world examples. The break statement is used to terminate the nearest enclosing loop prematurely. This can be useful when you want to exit a loop early based on a certain condition. In this example, the loop iterates from 1 to 10. When I becomes 5, the break statement is executed, causing the loop to terminate immediately. The continue statement is used to skip the current iteration of a loop and move to the next iteration. This can be useful when you want to skip certain elements or actions based on a condition. In this example, the loop iterates from 1 to 5. When I becomes 3, the continue statement is executed, skipping the rest of the loop body for that iteration. These are basic examples that illustrate the usage of break and continue statements in Go programming. They provide you with control over the loop's behavior, allowing you to exit loops early or skip specific iterations based on your program's requirements. Now let's go back to our infinite loop example. Since we have now covered the break statement, I can introduce you to something else. In other programming languages, this would be called the do-while loop. In other words, continue to do this until a condition exists, then stop. Go does not have a built-in do-while loop construct like some other programming languages. However, you can achieve similar behavior using a for loop with a break statement. This approach ensures that the loop body is executed at least once before checking the condition. Here's how you can simulate a do-while loop in Go. If we add a condition check within the for loop itself, we can ensure that the code at the top of the loop will execute at least once or until the condition is true, then the break will come into play and exit the do-while loop. Do-while loops are not something I have used often, but they can be handy from time to time. When learning a new skill, it's hard to know how to know if you have understood it correctly. So at the end of every lesson, I'm going to give you a short assignment. It should help you test to see if you have understood what we have talked about. The following video in the series will be me walking you through the assignment. So stay tuned for that. Anyway, here is your assignment. Write a program that takes an integer as input and determines whether it is positive, negative, or 0 using conditional statements. After that, add a loop that allows the program to continue working for a time. Come back and check my next video where I will walk you through creating this program. That's a wrap for our lesson 3 on control flow in Go. You've learned about conditional statements, switch statements, different types of loops, and how to control them using break and continue. Keep practicing these concepts, and soon you'll be writing more complex programs with confidence. Please remember to like and subscribe if you enjoyed this video. Until then, happy coding!